Hello everybody, I hope you're all doing well. Root Beer here, and we are looking at our second last question, question 24, on this grade 7 Gauss paper of ours. How many of the 5 numbers 101, 148, 200, 512, 621 cannot be expressed as the sum of 2 or more consecutive positive integers? So, 0, 1, 2, 3, or 4. So to answer this question, we really need to understand, well, how do you know if something's expressible as a sum of consecutive positive integers? And there's two ways. So the easiest way, if you've got an odd number of numbers. So for example, if I had a, and then another consecutive, so the number right after that, a plus 2. So if I had 3 numbers added up, turns out that's always a multiple of 3. Not only that, it's 3 times the middle number. And if there's an odd number of numbers, there will be a middle number. Same, for example, works with 5. So if I did b plus the next number, b plus 1, you'll have 5 b's. And then 1, 2, 3, and 4. That adds up to 10. And if you take out a factor of 5, you'll get b plus 2, the middle number. The reason this works is sort of you pair things up, b plus 3 and b plus 1. Well, this is 1 less than b plus 2. This is 1 more, and adding those up cancel out. We sort of get 2 b plus 1s. They balance each other. Okay? So that's sort of a nice rule. So if you've got a number, then it's a sum of an odd number of consecutive numbers. If n is a multiple of that odd number. Okay? Now, they were asking, I believe, for consecutive positive integers, and that might mess things up, because you'll notice nothing in my formulas assumes that a or b is positive. Okay? So that won't work for 101, because it's a prime. But 200 definitely is, 200 is a multiple of 5, for example. So 200 is 5 times 40. And that means 200 is, so 40 would be the middle number. So plus 41, plus 39. Plus 38, plus 42. And we've got a calculator. We can double check this out. But I know this is true. So 200 can be. Now, do we want can or cannot? Cannot. Okay. 621 is odd. It's a multiple of 3. So 621 is 3 times 207. So 621 should be 206 plus 207 plus 208. 6, 7, and 8 is 21, and 3 200s is 600. So yeah, that works out. I suppose we can keep track here. So 200's dealt with, 621. Now 512 has no odd factors. It's 2 to the power 9. 101 is prime. It's its own prime factor, which would be fine except we want 2 or more consecutive integers. And 148, I don't know the factors of 100. It ends in a 4, 8, so it should be a multiple of 4. Well, not should be. It is a multiple of 4. 148, you just quickly, or you can grab a calculator. But 3, 7. So 37. So 148 is a multiple of an odd number. It's 37 times 4. But if I go to turn that into a sum, we'll place 4 in the middle number. And then, for 3 minus 1 is 2 divided by 2, and you'll get 1 on either side. Same with 5. 5 minus 1 is 4 divided by 2. You'll get 2 numbers on either side. Well, you're going to have to do a lot of numbers on either side to make a sum of 48 out of consecutive numbers. And the problem here is their condition of positive numbers runs into a problem, because we'll actually start going negative. 148 is a sum of 37 consecutive numbers with 4 in the middle, but the problem is 4 is too small. So if 148 is a sum of consecutive numbers, we're not going to be able to use the odd trick because 37 is a prime, so we've got no other odd factors other than 1. So let's talk about how you make a sum of consecutive, a sum of an even number of consecutive numbers. And how does that work? How can we tell if that's the case? Okay. So consider something like a plus 1. You get 2a plus 1, a nice odd number. Okay. But you'll notice because we've got two numbers, there is no middle. I mean, this should be 2 times the middle of those two numbers, but there is no middle. So it's technically sort of like a plus 0.5, that sort of a thing. Okay, but let's take another look. So if I had 4 numbers, how does this work out? And then sort of what's the general rule? So I'll get 4 B's. That's not a problem, just like I got 2 A's. But then I get plus a 6. Okay, why plus a 6? Well, in between b plus 1 and b plus 2 should be b plus 1.5. That's the exact middle. And when you have an even number of numbers, half of them are going to be below the average, half of them are going to be above. This is different to the odd number case. So what you want is the number that you're adding up to needs to not be a multiple of 4, but you need to be exactly at a 0.5. You need the average of your two middlemost integers to be the same as your average. So it's not n that needs to be a multiple of 4, but 2n needs to be a multiple of 4. That's what we're looking for here. Okay, so n is a sum of an even number. And you can check this works for 6 and 8 as well. I'm just trying to shortcut some observations. So the sum of an even number of consecutive numbers if 2n is a multiple of that even number, but n is not. So how's that going to work for 148? Well, we're going to take 148, multiply it by 2, which I can see is going to be 296. And I'll ask myself, all right, is there an even factor of 296 that is not an even factor of 148? And there absolutely is. 8, because I doubled it, so I know 4 is a factor over here, so 8 should be a factor over here. You know, you grab your calculator, or you can double check it, but divide 296 by 8, you're going to get 37. Great. So how does that actually help us? So we'll have 8 numbers being added up. Which 8 numbers? Well, you take 148 and divide it by 8, and that should be this sort of middle number that doesn't really exist. Well, not that it doesn't exist, it's not an integer. So what's 148 divided by 8? We can see it's 18.5. Okay. Which means we're going to have 4 numbers on this side, 4 numbers on this side, so we'll have 18, 17, 16, and 15. And we'll have 19, 20, 21, and 22. Okay. And if you want to, double check, 18 and 17 is 35, plus 15 is 50, plus 16 is 66. So we'll have 66 over here. And then 20, 21, and 22, well, that'll be 63. Plus another 19, and then we'll have 129 plus a 19, and that's 148. Yeah, it works. Or grab your calculator, that's fine. I always try and practice my mental math just in case I forget my calculator, because that did happen to me a number of times when I wrote math contests in high school. Okay, but it works. And this sort of rule is how you're going to get a sum of an even number. So what does that tell us? 148 is off the list. How about 101? Okay, 101 is actually nice and simple because it can be written as 50 plus 51. But to show you how that works, double it. 202. Can I think of an even number that divides this but doesn't divide this? Well, 101 is odd, so 2. And so, sure enough, divide 101 by 2, you'll get 50.5. So that'll be the average. But you add those up, and you'll get 101. Okay. And then we've got one more remaining. I don't think this is going to work. 512. So I would guess right now. Somebody called time. I'll bubble in B really quickly. But I don't think 512 will work because it's 2 to the power 9. Okay, 512 has no odd factors. Okay. But if I double it, I'll get 1024. Can I think of an even number that divides this that doesn't divide this? Well, this is also a power of 2. The only factors it's going to have are powers of 2, and the only one that doesn't divide 512 is itself. So, yes, I suppose you could get 512. 512 can be written as a sum of, so it'll be 0 and 1. It'll be 1,024 numbers on either side. So it'll be 512 numbers on either side of 105. So you do 1 plus 2 plus 3, all the way up to 512. And you'll get 0 and minus 1 and minus 2. So just before 512, we'd have 511 over here. And you'll go all the way down to minus 511. And so things will cancel out on either side. And it'll all work out. But of course, they asked for positive numbers, so it doesn't count. So 512 just cannot be done. It's not a multiple of an odd number, so it can't be a sum of 3 or 5 or 17 consecutive numbers. And it is even, so it can be written as a sum of an even number of consecutive numbers, but they won't be positive. So that fails the other condition, and there's nothing we can do from there. So the answer is 1, which is B. 512 just does not work. Alright, so let's get ourselves a brand new sheet of paper in anticipation of the very last question, question number 25. I hope to see you there. Until then, take care.